Hello everyone, today my topic is about construction working of DC machine. So this presentation will cover the principles and components of DC machine, providing a comprehensive understanding of their construction and operation. So when we go to the introduction to the DC machines, we have some fundamentals and applications of DC machine. Fundamentals are direct current machines are electrical devices that convert mechanical energy to electrical energy or vice versa. Applications. DC machines are used in wide range of applications from small motors and toys to large generators in power plants. Next, principle of operation of the DC machine. First is electromagnetism. The operation is based on the principle of electromagnetism, where current carrying conductor experiences a force when placed in a magnetic field. Next, torque. The force acting on the armature produces torque, which rotates the shaft of the DC machines. Next, commutation. The commutator receives the direction of the current flow in armature windings to ensure continuous rotation. Next, main components of DC machines. Stator. The stationary part consisting of field poles, field windings, and a frame. Rotor. The rotating part comprised of armature, commutator, and shaft. Brushes. Carbon blocks that provide electrical contact between the armature winding and the electrical circuit. Commutator. A segment ring that reverses the current direction in the armature windings is called the commutator. And next, armature windings and commutator. Armature windings. Conductors wound on the armature core carrying current and generating torque are called armature windings. Commutator, a cylindrical assembly of copper segments connected to the armature winding, reversing current flow is called commutator. Next, when we come to field windings and pole pieces. Field windings. Coils wound around the pole pieces generating a magnetic field are called field windings. Pole pieces. Salient poles attached to the stator frame, providing a path for the magnetic flux, are called as pole pieces. Next, when we come to commutation and brushes, we have first commutation, which is the process of reversing the current flow in the armature windings. Next, brushes. Carbon blocks that provide electrical contact between the commutator and the external circuit. Continuous rotation. Commutation ensures continuous rotation by maintaining torque in the same direction. Next, we have torque production in DC machines. So first one, magnetic field. The field windings create a magnetic field in the stator. Next, armature current. The current flowing in the armature winding interacts with the magnetic field. Next, torque. The interaction between the current and the magnetic field generates torque. Next, types of DC machines. First one is shunt, field winding connected in parallel with the armature and the shunt. Series, field winding connected in series with the armature. Compound, combination of shunt and series field windings is called compound DC machine. Next, we come to the application of DC machines. First one is electrical vehicles, DC motors, electrical cars, and trucks. Next, industrial machinery, uses in cranes, conveyors, and other heavy equipment. 3. Robotics, powering robotic arms, actuators, and other mechanisms. Next, power generation. DC generation produce electricity for various applications.